So piggybacking off of what we learned with logs, sometimes when we can't make the bases the same, like what power do I raise 8 to get 4? It's a little awkward. So what we do is we say it equals some number x. Then what we're going to do is we're going to convert it into an exponential equation. So I get 4 equals 8 to the x power. Now that it's an exponential equation, the question is, how do I make the bases the same? Because if the bases are the same and it's an exponential equation, the exponents equal each other. We can assume that they equal each other. So I can rewrite 4 as 2 squared. I can rewrite 8 as 2 to the third, and then the x still needs to be there. Now those base 2's, those are no longer there. Divide both sides by 3. You're going to get 2 over 3. Now, the original problem didn't have an x in it, so you actually can't say x equals something. We just used x to help us solve it. For this, what power can I raise? 2. So 2 times 2 is 4, 2, 8, 2, 16, 2, 32, so that's 2 to the 5th. The log base 2 and the 2 cancel out, so you get 5. You can rewrite this as log base 10 of 10 to the 11 over 9. Basically, any root goes in the denominator of the exponent, so that cancels out, and so you get 11 over 9. And then base 36 and 36 cancel out, and so you're left with 216. Now, when it comes to finding the inverse, remember to cancel out a log or an exponent, we either convert it into an exponential equation or we convert it into a logarithmic equation. So we switch the x and y's, we add 2, divide by 4. Now log is the same as log base 10. So we take base 10 to both sides. So you get 10 to the x plus 2 over 4, that equals y, and that's going to be my answer. And likewise, to cancel out a log, or it says solve, so I have to think about what power, because the log and the 4 cancel out, so the log disappears, so I need to think of x as 4, because that's going to cancel out, and then I'm left with 4, so it's 4 to the 4th. So x equals 4 to the 4th, and then you could leave it as 4 to the 4th, or you can actually multiply it out. So number 1, you can go through, and how do I rewrite 36? I could say log base 1 over 6 squared. Move that to the top. So I get log base 6 of 6 to the negative 2. That cancels out, and I get negative 2. Get log base 1/6 equals 216. Now this is one of those, it's like, okay, how do I raise 1/6 to equal 216? So we can set it equal to x, change the base, so now I have to figure out what power can I make these the same, right? Because if they're the same, then I can set my exponent equal to each other. I can rewrite this as 6 to the 3rd, and if I move that to the top, that becomes 6 to the negative 1, and then times that x. So we get that. So now that the bases are the same, I can set the exponents equal to each other, divide by negative, so you're going to get x equals negative 3. But we can't have x equals negative 3, so we just need to make sure that it's only negative 3. Do the same thing here. 5th. So 625 is the same as 5 to the 4th. I can move that up to the top, so 5 to the 4th equals 5 to the negative x. And so x would equal negative 4, but we can't have it equal to x, so we just say negative 4. Log base 4 of 8. 7 equal to x, take base 4 to both sides because that cancels out. So we're converting it into an exponential equation. So 8 equals 4 to the x power. So that's 2 to the third. It's 2 to the 2x. So that's going to be 3 halves. Now for this one, the base 3 and the log 3 cancel out. And then the log base 2 and the 2 cancel out, and so I'm left with 1. Likewise here, those all cancel out, and so you're left with 1. So we're going to add 4. Then that's base 3, so we take log base 3 to both sides. This one, switch the x and y. To get rid of the log, you have to have base 4. Then add 1. Switch the x and y. Subtract 4. To multiply by that y plus 2 because it's in the denominator. You divide by the x minus 4. And then y equals 1 over x minus 4 minus 2. So we get log base 4. Now I have to rewrite that. I can write that as 1 over 4 squared. Move that to the top. Let's cancel out, so x equals negative 2. Cancels out, so you get x equals 5. Again, I know that the log canceled out, so that has to be a 7, and then for it to be 2, has to be squared. So 2 equals 2, so then x has to be 7 squared, which is 49. So to solve these, remember we pretend it's an equal sign. Put it on a number line. Open circle. Now we have to test true or false. So negative 6. If I plugged in negative 6, do I get true or false? And so 36 minus 42 plus 10, that's going to be greater than 0, so that's true. If I plugged in negative 3, 9 minus 21 plus 10, that's false. If I plugged in 0, 0 plus 0 plus 10, 0 is less than 10, that's true. You shade what's true. So your answer is negative infinity to negative 5, union negative 2 to infinity. So draw this 1, 2, 3, 4, up 2 over 1, up 2 over 1, right? So you draw the line. Now you have to test true or false. So if I plug a point, it's true, so you're going to shade the side that's true. If in the other one, it starts at negative 5, and it goes down 2 over 1, down 2 over 1. And now test true or false. So if I plugged in 0, 0, get false. So this side is false, which makes this side true. And where they overlap is going to be your answer. So this gray shaded area